This assessment asks us to show the reverse mechanism for the formation of the starting materials from this product under enzymatic conditions. The principle of microscopic reversibility says the reverse mechanism needs to be exactly the same as the forward mechanism. Bond for bond, arrow for arrow, intermediate for intermediate. So I've left up the intermediates from the previous assessment so that we can use them to prove the principle of microscopic reversibility as we go backward. So the first step of this backward mechanism will be for the base to remove this hydrogen. That's going to break the OH bond and form a carbon-oxygen pi bond. That's going to break this carbon-oxygen bond and use those electrons to attack this hydrogen. That will break that hydrogen base bond and will protonate that oxygen. That gets us back to this acyclic intermediate. In order to do the retroaldol reaction, we'll use another enzymatic base. The enzymatic base will remove this hydrogen, reform the carbonyl in the aldehyde on carbon number 4, break the 3,4 bond we formed in the aldol reaction, and reform the enolate. That gets us back to these two intermediates, the enolate and that original aldehyde. The final step then is to use generic acid to reprotonate the enolate. Take a pair of electrons from the oxygen to reform the carbonyl between oxygen and carbon number 2. Take the carbon-carbon pi bond, and carbon number 3 will be protonated to reform our original starting materials. This, using the principle of microscopic reversibility, is how we reform the starting materials from this product.